Master of the sun, memories falling on concrete, leaving all behind. Now you swear to be my enemy, victim of your cards. I'm running in the dark, I venture into nothing. Gone into the night, won't you come and hold my hand? Master of the sun, master of the sun. Master of the sun, memories falling on concrete, leaving you behind. King of silence in this reverie, victim of our cards. I'm running in the dark, I venture into nothing.
Hey Jay, what's going on? Uh, so I'm working on some like development for a flamethrower in like Houdini with so it's like a CGI flamethrower. Currently working on like some like fuel mixture stuff. So I can kind of show you what I have now. So let me pull up those images. So like this is just some like fire I was testing. Like there's some issues down here in like the down area, but like I was testing like the details and like getting the licks of some flames. This was like a really basic emitter, and then go down here. This is kind of like some of the more like the flamethrower is a little different than it was before, but you can kind of see like just getting the length and the stream. So yeah, I'm just kind of like working on that. Pretty much like the way it all kind of works is.
So bunch you just followed.
Hey, thank you for the follow, MD Subuntu. Oh, like the Linux distribution. So hopefully this could play, yeah. So yeah, so pretty much it's just a really quick particle sim over here. And then this particle sim has like some attributes for like fuel types. So we have like red for napalm, and then green for gas, and blue for diesel. Yeah, the workflow is like it's as complicated as you want it to be. So I want to do something that's a little more like physically accurate. So I kind of have to rebuild some of the stuff that Side Effects has in their normal Microsolver, which I've done in the past. I'm just kind of like redoing some of it. So yeah, so pretty much this emitter gets colored with different liquids, and I have like a user controller basically, so we can kind of control how much liquid density we want for everything. And that all kind of controls these kind of groups over by coloring, because basically like I'm running a flip or a liquid simulation from this emitter based off of these type of attributes, which I'm going to rework some of this too, but basically like gas, it tends to spray and burn up more, and then we have like napalm, which is more of like a viscous fluid. So I'm going to lower the audio a bit. So the napalm fluid kind of like sticks to surfaces, so I kind of have to redo some of that. And then diesel is like the middle ground where it takes a lot more for it to burn. Yeah. Oh, it's weird. I don't know why. Okay, this should be better, I think. Is that better? It was duplicating my audio stream, I think, after the Twitch alert went off. There you go. Okay. So we kind of get a flip simulation that looks something like this. And then based off of the fuel type, some of the fuel dies a lot quicker than others and some dies faster. So I need to rework some of the velocities on it. So you can kind of see the emission here. And I just have some coloring for the edge details. But like, this is another sim that I ran, and you can kind of see like how we're kind of getting different looks based off of just me dialing off those ramps on the fields. So this is something a little more extreme. And then I can kind of visualize my fuel here, so we can kind of see the different color fuels and how they're reacting. So that all kind of gets fed into a low res simulation here. So like this is like a really low res flamethrower, and we're pretty much using like the velocity field from this to make a higher res simulation that kind of flows in the same way but behaves more like actual like flames. So while I've been working on this, I've been kind of having one reference video up, which I should probably pull up here. And so this video I found, it has like a bunch of like mixing different fuels with like this one's diesel and gas with no napalm, with like some different looks. So ultimately we kind of want a look that looks kind of like this. They have a comparison down here, and I really like the middle video here where we're getting some flames and smoke, and you can see there's a lot of extra fuel that's not being burned down here, and it kind of like creating these little like tendrils of smoke. So ultimately we kind of want to get that type of look, and you can kind of see it here in slow motion. So since I kind of have like the overall workflow I think done, I'm kind of going back and just kind of polishing the different types of elements to it, because we have like this flame, and then there's the high res flamethrower that gets cached, which looks something like this. So we're getting like a lot more details in the flames, but it's still not quite like there, I think. So yeah, I'm just kind of going back and dialing some stuff in, and then after like this flame simulation's done, then kind of running it again, but just finding areas like where the smoke is gonna get like burning the fuel and creating the smoke simulation. And then we kind of go back. Then we have, after all that, we got to go into shading and work on the shading a bit. So yeah, that's pretty much like the whole thing. I've been working on it for like I think the last 2 weeks. I just started streaming like 2 weeks ago. So yeah, I'm just kind of working on this type of stuff. I'm a professional VFX artist that has worked in animation. So like I've kind of have a background working on a lot of different effect simulations, and this is just fire's kind of like the one area that I'm not that really comfortable with, so I'm just kind of thought it'd be fun to kind of learn it and then go back and then kind of teach it on YouTube when I'm done, like make a big old demo, like a professional, more polished tutorial than kind of streaming it live. So yeah. So the test I'm kind of running right now is I have these like 3 different fuels here, and I basically what I want to do is emit a flame in one of these fuel types and kind of control how fast the gas in here burns up for each one. And then when I kind of have that working independently for each one, then I'll go to the flip sims, and I don't know if I want to like do separate simulations for the different gases, or I'll have to figure out what's the best way to do that when I get there. So I've kind of brought in an older example that I did quite a long, I guess it was a few years ago, of like building a fluid solver from scratch. So like this is an example of something that I kind of learned a while ago. Rebuilding a lot of the tools that Houdini's made and using the same nodes, but simplifying and only really kind of using what you need versus like all the robust tools. So this is just kind of like our settings here. We have a smoke object, which is empty, and then we're specifying our fields here, which is just density and velocity, and then also bounds and source geometry. And then we have a SOP solver here that kind of controls our bounding box. And then we also have stuff for the burnout feeling. Yeah, well, I've been like pretty burned out at work, and I've been finding this is a little helpful with like kind of doing a personal project instead of working on like what I'm doing at work. So this has been kind of fun, at least for the past like 2 weeks, to just kind of mess with it and kind of see how it is with like streaming and stuff. Yeah, awesome. Have you used Houdini before? Oh, okay. Oh, so you're like just getting started with like have you used 3D at all before, or are you just kind of like seeing what interests you and messing around with it? So this kind of test that I'm doing right now is just emitting some temperature underneath the fuel, and what I'm hoping for is having this fuel start burning away, which doesn't seem to be completely working yet, which is a little weird because I think I have everything set up, or I might be missing like that one thing. So like in this version, I can kind of see it working. So like I have soot. This might be the soot we're seeing. Yeah. So we could see where the temperature and the fuel's burning because we're creating this soot here. Which that seems accurate, but what I should be seeing too is if I'm advecting the fuel with the velocity. So that doesn't seem to be like entirely working too much, which is weird because I kind of have to advect it as well. So I might have to look into like the advection tools here. Oh, nice. Yeah. Yeah, I've been using Houdini for like maybe like 8 years or 10 years total. 2 years in school learning it, and then 8 years I guess professionally. So this is kind of like me having a hobby, but then also yeah, like kind of like making content. So like my idea is just to make stream the content that I'm making and then make the content and publish it on YouTube, which might be fun, especially like if our industry's like always kind of dipping in a highs and lows. So um, maybe doing this on the side will kind of work a little better in the long run. Um, I would just say like do what you like, really. That's kind of like the best advice I could say, especially like after I've been working in the industry for like almost 8 years. Like doing the things that you enjoy the most, I think, and in the long run you'll like it, and then you'll also meet other people that have similar interests. So yeah, I think that's like my best advice I can give. Yeah, no problem. Okay. That's all updating the fuel. And I need to advect the fuel. Maybe I shouldn't advect the fuel. I'll just try turning up the temperature and see at what point this stuff starts burning. I'm doing pretty well. How are you doing? Just kind of working on some more Microsolver stuff in DOPS. Kind of rebuilding the temperature workflows. In the newer Pyro, they got rid of the like using fuel for combustion, and like calculating fuel spreading. So I'm kind of like trying to get it back into sparse Pyro, which we kind of have something working, but not quite. So I'm just kind of going into all the microsolvers that they made and messing with stuff. Which is always kind of fun. No, this is just more for a personal project. So, I've pretty much just kind of want to do a personal project and then maybe make it into like a workshop online. Because like the end result is just the flamethrower like reference that I want to do. So I want to make something that looks like this, like photoreal, and then have a polished render finished, and then do like the tutorial for it. And then after that I'll probably move on to something a little better. I kind of want to do like 2 or 3 of these, and then I could start advertising it on like my personal LinkedIn and stuff. Especially if I start building like a following a little more naturally before like advertising it. My YouTube is here. I'll link it. There you go. Oh yeah, Sparks with some coffee. Yeah, the fire setup is kind of like in a standstill right now. I'm just kind of reworking some of like the early setup. Like since we kind of have the overall setup done, it's kind of just going back and reworking some of the things and polishing some of the stuff. Like I want to polish the flip sims a little more, and mainly the pyro solver too, and see if I can make it something a little more polished. Which that's kind of why I'm going back into this like combustion solver, which just fun. Yeah, it is, but like you kind of like understand it more afterwards. Like I find like cuz like the temperature nodes in Houdini are pretty much just like it's just this gas buoyancy node, and there's really not a lot of control, so it's like it's fun like going in and try to find better ways to control things. Which the combustion one's a little trickier, but like the way they calculate combustion is like just these nodes here, and a lot of them are just duplicates of the same one, just doing some like easy math operations. Like the linear combination mode is just like a math operator, so here they're just taking the temperature field and adding it to the burn fields and using a constant of -1, so they're kind of like subtracting whatever is being subtracted together, and then like here they're just clamping it, so making sure that I guess it never gets negative in the field. And then like this one is just taking the burn and the gas or the fuel, and then doing the minimum solve and putting it back in the burn. I kind of got inspired for this one because Weta did like a talk on like combustion a couple years ago at SIGGRAPH. So like when I was at that talk, it was pretty inspiring, and they're basically just showing like their tips for like how they shade their explosions, which side effects is kind of updated in some of their tools. So yeah, it's pretty fun. Like it's just getting a little tricky because I'm just trying to make sure everything's working right now, and it seems like half of the stuff I'm trying to do is working. Like because what I'm trying to achieve right now is our fuel here that's green and a temperature that's rising. Is fuel should actually start being advected by the temperature when I have my little checkbox set. But it looks like it's not being advected by it, which is very strange because like all the other like nodes that I'm having, and I have like the gas advect node, which calculates the velocity here. So like there's a gas advect field, so I should technically just be able to drop one of these down and like plug it in here and then say our fuel, which is our fuel gas, because I'm trying to have 3 different types of fuel that we could source instead of just one natively in Houdini. So I should just be able to plug this into the gas advect here and say our velocity field is going to advect our fuel gas, and like when I hit play it should start advecting the gas, but it doesn't really seem like anything's happening at all. Which that means that there's something kind of wrong somewhere along the line of something not working, and it might be something wrong with actually it doesn't seem, this is like my scratch solver, by the way, so all of this is just kind of like made from scratch, testing like the different fields. So like if it doesn't work here, then I know it's not going to work in the actual pyro setup I'm making. But if I can get it to work here, and if it doesn't work in the pyro setup, then there's something wrong with the pyro, the standard pyro tools. They're preventing it from working. Which maybe I shouldn't allow self-advection. Which I might be testing, making sure the sourcing's working. So I really like this node in DOPS, the gas intermittent solve. So you could always just make sure if you want to emit something once, it always just kind of emits once. But I need to offset it to 1001. Hey, good morning, Iload. And yeah, good evening for me. Yeah, so see it's working here. So the fuel's getting advected here. But when I turn off the emission every frame, our temperature's working. But then our fuel is not getting advected. Like, what's confusing about it is everything's set to copy, so they should only set it once and then kind of leave it alone. But that makes me think that something along the lines here is breaking the whole setup. So Iluad, the thing I'm working on is kind of rebuilding some of the pyro solver tools. So because the newer pyro solver has taken out the fuel sourcing, because they want you to like build it all into SOPs with the pyro spread, which is like it is art directable, but like if you're doing something that has like, you know, fuel types, it can get, you're like, what do I do for fuel now? So the idea is taking those flip sources that were created and then using fuel emitters for each one. So then I could have like 3 different temperature fields that are all controlling the napalm, the gas, and the diesel separately. No. No. Yeah, I want to see if I could take it like a step further. It's the same project, yeah. Yeah, so I'm just kind of I want to see if I can polish the pyro emission a bit. And then there's some things I want to mess with the flip as well, with like because I was reading about like how gas and diesel, since they have different viscosities and different burn rates, like I need to maybe go back and make sure that that's being like held accountable. So then there's like a little bit more realism into the effect, you know, and instead of just like emitting fuel and temperature by default. So I think maybe having 3 fuels and then advecting like 3 different temperature fields could definitely take the look in the step up in the next direction, because if they're in separate fields, then I can dial in the details for each one dependently, instead of like trying to just apply like a global turbulence, you know. Which it seems like the volume source might be maybe I have something checked on here. Oh, wait, is that... Actually, this would probably help if I turned off the temperature. Yeah, so that's not doing anything. So that's a little frustrating that... Oh, you're learning how to drive? Or are you teaching someone how to drive? Yeah. Driving's the one thing that like I like love it and hate it. I have like somewhat of like narcolepsy and sleep apnea. So like I can't really drive more than like 40 minutes or else I get really sleepy. And I'm just gonna say to this day is like I'm gonna blame my parents for letting me sleep in the car when I was a kid. Because now anytime I'm driving I just get sleepy. Yeah, everyone in the USA is like, oh, I need a car. But everywhere else it's just like, you know, you don't really need one. Oh yeah. Yeah, but I mean, driving's just kind of like riding a bike, you know, like once you kind of get comfortable behind the wheel, it's a little better, but it's pretty scary. Like we've had a couple drivers, because like we have like weird insurance. I don't know how insurance like drivers insurance is in Europe, but like here, like depending where you live, that's kind of how they dictate the price. And like where I live currently, it's one of the worst drivers in the state of California. So like where I live, it's people with really expensive cars that are driving them like the biggest assholes on the planet. So like it's very expensive insurance, which is like super frustrating. Okay. What kind of car were you driving? Hmm. When enabled, merging into a non-existent dot field will cause this node to create a field of the appropriate name. Okay, so maybe it's being overwritten. Oh, nice. Yeah, so the tricky thing with electric cars, from what I heard, like I drive, um, like I bought my first car maybe 3 years ago during COVID, and it's like an older BMW, which I mean I love it, but it's kind of like a gas hog if I drive it further. But yeah, like I know with electric cars, the issue with them is like after 10 years, you might have to get a new battery, and like the new batteries cost like insane. Like it's almost like buying a brand new car with the batteries. Um, so I've heard leasing them is like the best thing to do. But then you know you just can't like go over that mileage or whatever. But I mean, we do need to have electric cars though. Like it's kind of we're kind of at that point, you know. Nice. Yeah. Well, I mean, you guys are like definitely trying to get more electrical and getting everything together than I think we are in the States. I think in the States, you know, we're just like, you can't take our cars and you can't take our guns, which I'm not really opposed to both. I'm like, you know, if you need to get rid of them, just get rid of them, please. Make 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 it better. Okay. So if I don't have that field, gas hybrids. Oh, I feel like that's still somewhat better than nothing, you know? Like because then at least like you're not always using the gas in the car, but yeah, like I feel like at a certain point it's just like, come on, just we just need to fully commit. Okay. Yeah. Yeah, I definitely want to get like probably a more fuel efficient car, especially with like this industry and how scary it's getting. It's like I'd rather have like a Prius that has like the best gas mileage and looks like the worst car to drive than maybe something that I'm driving now where I'm like having more fun enjoying it, especially because like it's a little more speedy and picks up the pace. Oh, I can imagine, yeah. Because you could like upcharge as much as you want, but you know you're barely using any of the gas. Okay. So I'm wondering if sourcing has to be in a different spot then. So if I'm calculating all the advection after the sourcing, maybe I need to calculate the sourcing advect and then add the extra fuels. So let's see if this works. Oh, Is it working? It is. Okay, so that worked. And doesn't look like it's working as well as it should, but something's working. So now I just need to make sure that. Oh, and that's just advecting it here. So I need to test it now with my solver. So the way this solver kind of works is there's an option for advecting fuel here, which is just the gas advect node pointing to the fuel, which I need to change. And then it's calculating all the fuel that's consumed by the temperature, and it just outputs it to the burn rate. And then if soot is advected, which is like an extra density field, then we can plug that in. Are all the driving apps like pretty popular in Europe, like Uber? I imagine they are. Like Uber and Lyft and stuff, or is it mainly just like taxis? Oh, that's cool. I think it's working. So we should see a hole burned in the fuel here. Okay. Yandex. I'll look that up. Oh wow, that is super cheap. Yeah, so I live like 20 minutes away from an airport that I use, like the Burbank airport, and a taxi was like $15-20, or maybe not even. It was like about 20 minutes away. So like they're charging almost like like $1.50 or like $2 a minute, like, and it's not even that far. It's like maybe like 3 or 4 miles, but I don't know what that conversion is in meters. I should. I use Houdini. Let's see. The burns purple. Is this the soot? It is. Okay. So that I just think I need to make sure that it's using the fuel gas, because it looked like it wasn't. So I put fuel gas there. Naturally, everything breaks. So bell, except so do everything except fuel. And then something in here is breaking now. So interesting. So if this should not advect it. sure it will. Hmm. Okay, so temperature goes to burn. So should be seeing a burn field too. That doesn't seem. I swear they've made it a little harder to get this stuff all working. Okay, we can kind of go to the Scratch solver and test it out to here. If we test it, okay. See if we can get it working like on a 2D fluid. Which I think we can get it working. Let me test it with this other one. Yeah. Yeah, 2D fluids could be fun. Oh, that's not gonna have 2 control. Okay. No, that's not working. Hmm. Yeah. Oh, if you actually want to see something really cool, one of the supervisors I worked with at Disney, let me pull it up. So yeah, he made a 2D fluid solver from scratch, but it works on geometry. It's so cool. And there's a hip file too if you want to like look at that. I'll link it once I find it. Yeah, this is like the test that he did. So like, yeah, I think it's using like OpenCL, but it's pretty cool. I haven't actually looked at the file, but you can kind of see some of the tests here. Yeah, his name is Jake Rice. He is a genius. Yeah, he's a really nice guy too. But yeah, he's done a bunch of really cool things like I've used this optimal transport one before. This is actually a really cool one. Like that opening shot on my reel with like the Wade's head exploding. The guides, like, because I used like SDFs for guide shapes, but I use this optimal transport to calculate the guide positions for the flip fluids. Um, Super cool, yeah. Okay. So if I turn off all of this stuff, get that. Okay. So that's just the buoyancy and velocity. Yeah. Okay. Use a volume source. Then just do first context. Density. Density. VDB from particles. And then we'll just rasterize those velocity points. I'm gonna turn that one. That's a little too trippy low-fi for me. All right. Okay. So I'll just do like 0.1. Okay. And then I don't know if that's a bounding box that's causing that. Let's do a default buoyancy of 1. Okay. So I'm gonna turn this density into temperature. And then the buoyancy temperature. And then density to temperature. Temperature. I'll just name it all temperature. Hopefully it works. Good. Okay, and then buoyancy. Okay. So now I just need to do one for fuel and Honestly, I'm just gonna transform the source. And then name that fuel. Oh, I gotta love debugging. Okay, so merge. So we have velocity, temperature, fuel. And then need to create a field for fuel. So duplicate that. Make the field green. And fuel. And then copy. Or, sorry, fuel. Goes to fuel and copy. Okay. Yeah. Yeah, so here it's using the gas project non-divergent here. Oh, the VDB project non-divergent? No. No, actually, that actually might be. Yeah, let's do that too. I've heard that it's actually better to remove the divergence in your sources, but I've never actually done it. Okay, so the fuel's born, or the temperature's born. Mixes the fuel. Okay, this will be a good test. So I'll copy the gas temperature and the gas combustion. Delete these. Okay. So we could get rid of that buoyancy. We should see some buoyancy happening here. And I'm gonna increase it. Okay. And then we had this gas combustion. So if we set that to fuel, we should get some sort of reaction. Actually, no, we won't, because I need to make. Wait, no, we already made the fuel. Yeah. Also need to resize fuel. And then we also need to advect. Well, if we do that here, this should advect the fuel. Yeah, so the fuel's getting advected here. But then that's set to copy. But it seems like when it copies it, it's not actually removing it from the original source. Which that seems like that's wrong. So if I plug my own in here, I put just fuel. Okay, so the advection stops working. Even though specified there. But if we go inside, gas advect, fuel. So if I just plug this in, this should just literally advect it like we just saw. Okay, it is. So that works. Okay, so we go to the next node, which then takes the temperature field and adds it to the burn field. So we need to make a burn field now. This burn, and then you'll make the burn purple, I guess. See what that looks like. Okay, so there's the burn. And it's not resizing, so you just add burn to the resize. Save. So, okay, so temperature goes to burn, and then we're maxing the burn. Yeah. So that is if you're, I'm guessing you're using, when you did that, was that like a sparse pyro? But the main reason why that occurs is because there's usually not enough, like you can kind of see our bounding box here, like on the 2D level. So if there's not enough padding between your source and the bounding box, when especially like if it's fast moving and like substeps, so like it'll keep expanding, but what ends up happening is your source might be going to the edges so quickly to the point where the expansion's not big enough occurring. Like here you can see like there's like always like somewhat of a gap like on the leading edge here, so there's just enough room for it to always expand. So the way you fix that is let me open up. So the Microsolver here, like the quickest way you could probably fix that is go to the bounds here, and then there's the resize. So yeah, so you might have to increase the padding here, but the thing that sucks about doing it here is this is a global expand. So if you expand it by like a padding of 2, like X, Y, and Z in positive and negative space are always going to expand consistently in the same like just as wide. So if your explosion is just going upwards and you know everything else, all the other sides are correct, then what you can actually do is go inside the sparse pyro here, and we can go inside the DOP network, and there's this Microsolver right here, so you can allow editing of contents here. And then there's actually, I think we have to go one more inside the smoke solver, inside that Microsolver, and then inside here to the left there's the resizing. So we can see that there's like the gas resize, and actually inside this, I think inside this soft solver, there's a bound. So you can actually break it here if you wanted to, because you can see that padding and that UI is being set here globally to like all of these. Not on the edges and for a few frames. It could be. My guess would just be it would just have to be either something to do with like some sort of expansion with the fields being infected, or maybe there's just not enough substeps. to calculate it. So like that might be a good example of like messing with the min and max up steps here. So like maybe going from like 1 to 5 and then setting the CFL condition to 4. Like maybe that could help with the sub steps there. It could be. Yeah, what could also be happening is your velocity is so high, it's literally tearing like the fluid within like those voxels. So what you could try doing is like clamping it or just lowering it, but sometimes clamping the velocities is better because then it never goes past like a certain limit or a certain limit. Yeah. Yeah, we'll take a look at that. Like that might be like the biggest, or like those might be the dead giveaways. But it never really hurts to have enough like expansion too, like just on the leading edge. Especially for like the big pyros and like explosions. So if we go back here, we have so it's clamping the burn. So now we're calculating the fuel consumed. So we should start seeing the burn start subtracting the fuel, which I'm seeing it here. Maybe it should actually be set to subtract. No. Something did happen though, because we're seeing the burn like this, and the burn is copying into the fuel fields. This will be a good go into the gas combustion node. So yeah, so they have it set to subtract. Yeah, oh, okay. I'm gonna break all of this. So you can see I'm just kind of taking their combustion field. Because I really I think this UI is like very like, I don't know what the hell's happening here. And I've kind of made my own that has somewhat cleaned it up a bit. And that was for like that explosion that's like in my logo. Like this one here is like, this is the same setup I used, but I'm just kind of cleaning it some more. So if we paste this in here, we could go. So this should be set to subtract, and then taking the burn. So burn here, burn there, and then that should be set to 0.1. And set always none. Well, that might be why that was failing before. And then this one's the E time step. Oh. I mean, something's... I don't know if anything's happened. It looks like something's happening. Let me disable. So it's just not being advected again. Like, why? Subtract. So the green source here is the fuel. So the idea is, when the temperature gets to the fuel, we'll add the combustion. So the flame should get larger. There's actually no velocities right now. Yeah, so right now it's just it's temperature and buoyancy, and the buoyancy is just well, we're not sourcing any velocity. This is actually just the simulation velocity that we're seeing, but we are advecting our fuel here, which seems to be somewhat incorrect. So we could just go to the next node. So inside the combustion node, they have the update fuel. So maybe we just need to update the fuel after, which I probably have wrong. So fuel source burn 1 minus the inefficiency. Okay, so this one was correct. This set to scalar. Oh, maybe these all need to be set to scalar. Oh. I mean, that's different. Fuel burn. Fuel inefficiency. Oh, the fuel inefficiency. And after is the normalized burn rate. Sorry, I almost had to sneeze. Field source. What is the field? I guess maybe they're advecting the fuel after. I thought they were always advecting it. Okay. So maybe we need to advect the fuel after. This would be a good time to practice here. So turn off the burn. Okay, so nothing's happening with the fuel again. Fun. Okay. So go back here. expected. Temperatures burning. I'm gonna go back to, so this file here is the main one that I've used before, which I'm kind of what copied over. So add, I'm gonna actually open this up on the side window. Okay. Back fuel. Temperature to burn. None. So that constant has to be set to none. So maybe it was that constant that was messing some things up. Okay. And next one, constant is set to none. So that's just clamping it. It's kind of an interesting look that we're getting. And then the actual fuel consumed is also constant set to none. So it seems it stops advecting here. So there's something with the fuel consumed causing this. So subtracting burn from the fuel. Maybe it's this global. Yeah. Okay, so it's this. Oh wait, no, I have it turned off. So if I set these to 0, I guess it's not actually subtracting it properly, but we could try using a wrangle. Guess. So we could try saying F at fuel minus equals burn. So is it subtracting it? It's doing something. Looks kind of cool. Goes burn, and then I guess I'll just clamp the burn. So just try to make sure it's always 0 to 1. So the math here was the burn rate and then the constantly subtracting 10%. So minus 0.1. Negative 0.1. So fuel minus the burn, clamped. I guess I could multiply it by 0.9 and that'll be the same thing. So multiplied by 0.9. So that should start taking 10%. And then we need the actual burn rate. So this one, maybe I'll just do like CH burn rate. And then multiply it all one more time by 0.9. So the burn rate's not 0.9. It should always be burning. Yeah, that looks like it's working. But if that's set to 0, we're seeing a leading edge here. So I don't think we were seeing a leading edge before. Okay, so this seems like it's working. We'll test this later in 3D, see if this works, but maybe there's something wrong with the linear combustion and that's why they took it out. But I think this wrangle is doing kind of what the math was doing there. So next is updating the fuel. So fuel's getting updated. Oh, I need to link my parameters. So how's the burn rate calculated before? Burn rate. Okay. So we have the burn rate back. Fuel gets updated by the fuel inefficiency. So if it's very inefficient, it should not burn as much. Actually, I need to turn this back down. Okay, let's actually test this in 3D. So this is what I really like about it, because then we could just uncheck the make 2D. And now we could kind of see what's kind of happening in 3D. So, oh, there's some weird stuff happening. Okay. So let's see where that's going wrong. Which might, you know what, honestly, might be my wrangle. That's messing this all up. Okay. That gets ejected. So fuel equals the fuel minus by the clamped burn minus by the burn rate Oh, I think this needs to be the opposite. Sorry, the burn rate should maybe be the opposite. That seems like it's working. I just don't get why the fuel, so this fuel should like not be here anymore if it's set to copy, which maybe that's changed too in Pyro, but I think do the 0.9 burn rate. Let me go back and turn down the inefficiency. Let me try pasting this old node. This is the old one that I had. Okay, so actually, and now I'm thinking about it, this is correct. So we should see only the areas getting burned near the fluid. That actually I think is correct. Yeah. Because then this should update the fuel, which I don't get why the fuel just stopped vecting. That's the only thing that seems off. Copy. fuel minus clamp burn. Not clamp it. Open, open. Close, close. I should just say if at maybe it's always inside the fuel. Okay, so the burning very low burn rate. Okay, so that has a low burn rate. So if we, oh sorry, that needs to be 1 minus. So now it should have a very high burn rate. So that fuel should start getting consumed. Update fuel. Fuel. There's something with the burn causing all these like artifacts to happen. Which maybe I shouldn't be calculating a maximum burn. So this looks like the combustion. So that's so strange. So it looks like the gas combustion tools are having a very similar issues. Which doesn't make sense because if I update the fuel here, do fuel consumed. seems like it's working. Maybe we just need to always clamp the fuel. So then it just never goes over value of 1. And then afterwards, reduce it by 10% each frame. Yeah, so that's burning all the fuel up. Okay, so the fuel's getting burned. And if we turn down the burn rate really low, we should not see as much. I think it still has something to do with reducing it by 10% each frame. So maybe we just won't do that. So then the burn rate just dictates how much of that fuel is burned. Yeah. Okay, so that should update the fuel. The inefficiency. We're not seeing anything super weird. Cool. And then gas advect. This is going to advect our fuel. Wait, that should not. Okay, yeah, no advection of fuel there. So this should normalize the burn rate, which I feel like that's always been the issue. That got me curious. Maybe that would fix that issue we're seeing here by normalizing it. Yeah, that still looks weird because it's not advecting anything using this linear combination node. Okay, and then update the soot. Which so soot is equal added to the soot, and then we're advecting the soot, and the burn is equal to the soot, and that should update the density. So I think I just need to add a soot now. And we'll make the soot blue. So should start seeing some soot being created from the burn field. There it is. Oh, I need to advect that. So do soot here. Temperature val. Okay, so wherever the temperature burns the fuel, we should see the extra soot being created, which is blue. I'm seeing something. So that's the soot. Which that actually doesn't seem right because there shouldn't be any soot here. So strange. I don't know why like any of these older nodes that I have aren't working. So I guess I was also calculating the divergence before the temperature. So I could try this older one. And then setting that to 1. Fuel. Yeah, that's strange. Hmm. See if normalizing the burn right now. Doesn't look like it's breaking anything. And then update the soot. Eject the soot. Okay. So that's wrong. Still, so the soot. Not gonna make that into density. Yeah, that's not right because we eject the fuel, use fuel, eject fuel. Okay, so that still seems wrong even with the update, but temperature, copy to burn. Actual fuel consumed. Fuel inefficiency. Okay. So that's still wrong. So we have soot being added to soot, advecting, soot, updated, burn. look at the combustion. So update density, soot, burn. So soot burn, the coefficient is the soot rate, which is the soot amount for me. 0. Sorry, 1. Add. Hmm. Set burn rate. Effect fields. One, two, one. Burn. Um, Potential fuel to burn. So that is burn. Burn active. And then we need to plug in fuel. And then burn. So let's potential fuel to burn, and then we have clamp, which is burn maximum scalar So the coefficient, you need to look into some of this stuff. So the coefficient here should be 100. Burn. That's it. Okay. And then temperature to burn. And that's set to -1. Okay, so I was missing quite a bit. It's a scalar. And the constant. Okay. So temperature is now interacting with the fuel as expected. So temperature is going to burn like here, and then maximum burn there, and then heat. Sorry, not heat. Potential fuel to burn is fuel burn minimum burn. Fuel burn minimum burn. And then 0.1 burn rate 1. 0.1 burn rate. So copy the burn rate. And then that gets updated. So fuel inefficiency. We normalize the burn rate. So that's affecting update density. Okay, so I need to normalize the burn rate after it's been made into soot. Okay. Divided by 24. That's the total coefficient, the scalar, okay. So total coefficient, scalar. Okay, so we should have a working field here. Yes. So we have soot being created at the burn or the temperature. And then the fuel should be getting burned. Yeah, I'm gonna save. I don't wanna lose any progress. So now we have gas calculate. Wait, so that's going burn, fuel, multiply. So do I even need to do that? So I guess not. We get to see what that looks like. Yeah. Okay, so actually I don't know if I like that or not. If we have the burn rate really high, we should just see almost it get completely broken up. No. Okay, maybe we do want that. So that should still burn it pretty quickly. Almost entirely, okay. And then turn down the burn rate. Yeah. And if we dial the inefficiency, hopefully that does what it should. Turn those both very low. Okay, now it seems like, yeah, it just seems like when it's getting multiplied, it's just getting rid of everything. Should probably also send the multiply to 1. Even though I don't know if that's doing anything. I might have broken the whole UI. Make sure this is working in here. So temperature to burn, max burn. Is the potential fuel to burn? Yeah, it's all set to 1. Okay. So, and then we fuel consumed. Just set to subtract, burn rate, and efficiency. Okay. So update fuel efficiency. Something's not right. Okay, so if I say do not advect, you should not see the field getting infected. And then we lower the burn rate and increase the inefficiency. What did they do for the inefficiency? So it's just set to 1 minus subtracting fuel by fuel. Okay, I'm gonna take it. So if we crank this up now, we should see that high burn rate, hopefully. Higher burn rate, and then hopefully less soot. And then I guess we subtract or edit that here. Cool. It is very hard to tell if doesn't seem like the fuel's actually getting burned now. What is this? Bad parameter reference, OpenCL. Burn. So update fuel. So they're the inefficiency, but that's just set to 1. So it makes no sense. I'm gonna test this on our 2D view. So turn off fuel. Turn off temperature. So there's no burn showing up ever. That's fun. And then so it, but if I have the burn rate lower, so we're getting everything seems to be behaving more. Maybe it's just the inefficiency. I guess it's working. So if I say I only want 10% soot, I should get less. Hey, trying to recreate a lot of the Microsolver functionality that they took out with the new one, like so the new like sparse pyro. Oh. So the pyro sparse, no, that object. Smoke object sparse. So the new sparse smoke object, like they took out fuel entirely because they're trying to do the new like soft spaced fuel stuff by just like having you like animate it yourself. And like the new Microsolver doesn't use fuel at all. So I just kind of created one quickly from scratch. So like we have a temperature here that is interacting with the fuel and creating soot. And then the pink is where all the burning is occurring. So we're getting all that natural like burning occurring in the pink. So I think it's kind of working now. It's a little tricky. Like I tried just taking a node that I made a while ago, and that node kind of doesn't work entirely anymore. So I'm just kind of like looking at clinging to the past. well, the reason why I'm doing it is because I want to, because like Weta uses it still. Like that's the main reason why I'm like, they still use stuff like that. Like Weta and ILM, they still use like very like scientific based solvers. So I was like trying to do something like between it. So my idea is, for the flamethrower, I want to have like 3 different fuel sources. So basically like 3 different temperatures. So I'll have like a fuel for gas, a fuel for napalm, and then a fuel for diesel. And then the temperature should just ignite and combust those wherever the fuel and the temperature meet for the source. And I think that can give us a little more of a better read. It might be harder to dial in, but I think it could give us an interesting look. So it seems like we finally got the fuel part working. So we're getting the fuel and the soot and the burn all kind of working now. So I just need to clean this up in the UI, and then we should be able to put it into the Pyrosolver hopefully, and just hopefully it just works. Temperature, burn, and fuel. Okay. Fuel. And that's soot. That's it. I guess I should test the divergence too, because that's what's gonna be very messy. So hell, I think what is divergence? It's a smoke. I think it's a vector field. Divergence. It's a scalar field. Okay. Sorry. So divergence. And that orange, I guess. Okay. I need to resize the fields. Temperature. There's divergence. So the divergence is created with fuel. It's a divergence. I think that's wrong. I think it needs to be burn. The burn needs to be the divergence. It's hard to tell if that's working. Because our burn is the purple, right? So, yeah. If we crank this up to 100. It's hard to tell if it's working. Let me actually wait, something. How are you doing? Okay, I think that's working. Save. Okay. So this is what we had before, where nothing was working. So we could try gas divergence now. Oh, I need to specify my fuel too. Sorry. So use fuel gas. Let's see what this looks like before anything happens. There's something weird happening too with pyro, like the new pyro. Like I'm creating all these fields and it looks like nothing's happening, which nothing technically is happening. And the main reason why I found out nothing happens is because this volume source node is doing something. Like if I gas intermittent solve this and we do it only once, but then set this to 1001, or sorry. Okay, are you just not gonna? Yes. We could even try the enable solver. So if I set this to 1, then 0. Okay. But you can see how if it just emits on one frame, all of this stuff seems to be working. But if I constantly emit with pyro source or the volume source, it, for some reason, it's not working properly. Like, cause I'm seeing the fuel in the soot now mixing. And there's no more temperature, so nothing's burning. Which, like, this is what I'm expecting. But then, if we do this, now nothing's working. And I thought copy was just initializing it for the first frame and not keeping it per frame. But maybe I need to set this, the fuel to copy. But temperature's already set the add, so. But I guess it shouldn't be copying. Maybe it should just be set to add. Maybe that's what I've been doing wrong. But I don't want to add it every frame though. Like, I don't want the source. Or maybe, oh. Is that, I guess that's max. Copy overrides the whole thing. Okay. So I guess if I don't want it to increase in value, it should just be set to max then, right? I'm guessing that's what I'm missing then. Well, the only reason why I found copy useful, I guess this makes sense why I've only found it useful in this way, is like if you're plugging in a velocity field from like something that you've already cached out and setting it to copy, then it's not like increasing that value. But I guess it's still weird. Yeah, I don't know. Okay, so this works. And then this is the regular smoke solver. So now that it works with the smoke solver, I need to test this with the pyro. I guess it could just be a sparse smoke solver. But maybe since this is going to be more of a tutorial, I need to do it with the pyro. But or a workshop, if this works out well. This might be a disaster. Okay. So volume source here. I also don't know why they changed like all these input orders, like why sourcing is the second input now, and then you have forces. I don't know why. It just feels messy now going in here. Plug this in. And then so we have set, burn. Hell yeah. Okay, so that works. So it should be blue. Turn up the burn rate. Yeah, the soot emission doesn't seem to be working. What if I change here in the volume source though? The gas. So this. Wait a second. Add. Add. I guess I should make one here for soot too. Even though okay. Okay, so I just want to test a frame like this then to make sure we're seeing everything. So that's a gas. I'm not seeing any soot. And the burn should be purple. Oh Lord, what is happening? Okay. That's this one more time. So temperature to burn. Oh, this is that stupid issue. I think here. Fields. want to try something. So if I okay. Mm. Seems like just all that work I made to make sure the fields were being created, it just threw it, all of that out the window, which I think that's a solver error. But burn. Okay. So specifying a soot and a burn there. Seemed to fix it. Put the burn rate high. Okay, so we're getting the combustion. Oh, that I'm gonna get away from that frame. Okay. Okay. Moment of truth. So ideally, it'd be nice to have 3 of these. next one would be fuel napalm. The fuel diesel. Fuel napalm. Okay, save that. Oh. So I do not want to infect any fuel. Okay. Okay, so gas tends to burn faster. So I'm thinking having that as a higher burn rate. Maybe we should infect it. Very little soot. Oh. Okay. And then for the temperature, give that a very high cooling rate. Diesel. Okay, so Centroid. That's your input. One. X. Y. And Z. So maybe it actually is going to be worth doing the whole multiply by burn. No. Yeah. All right. So if we do lower burn rate, okay. So if I animate the temperature now, on. No, don't solve. Yeah, honestly, I don't think this is gonna work. We'll see. This was a fun exercise, I think, nonetheless. So, click here. So we have temperature being sourced. Goes into the first field. Well, I should probably turn those multiplies off. So multiplies are off. Okay. So temperature is going to go into the diesel and ignite that. Hopefully. Nope. Okay. Or something happened. Getting some very interesting chain reaction type stuff. Okay. Okay. we'll switch. Only do this one. Advact fuel. Okay. And then let's have like little to no soot. Cool. And we'll give it a higher burn rate. And the fuel does need to be, I think, very inefficient because it's the diesel. So that should just be the fuel getting infected with very little coming out of it. But I think we do want some. So lower the burn rate. Okay, now there's a lot still happening. Turn that back up. So let's see what else they're doing. Update the heat. Heat, temp divergence. Yeah, this stuff's old because they're still using heat instead of flame. If any of this stuff would be worth it in here. Active. 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 flame. Versions. Burn. Ugh. Okay, so that one's fine now. Fine. Fine. So that is gas release and burn influence. So that is where are they using gas release? Oh, um, make a float. Then I'll just put gas released here. And for burn influence, burn. Update divergence. Extract core. Gas burn influence. Jesus. Once. Okay, I'll just use the burn rate. The heat, that. Update temperature. Heat output. Temp heat influence. 1.8. Update temperature. Clear temp field. So calculate burn, calculate divergence. Okay, we'll see if it keeps the temperature field. Hey, basically it's the same project. It's just we're messing with the microsolvers and Houdini. So, pretty much what's happening is the pyrosolver in Houdini, they used to calculate things like fuel, but now they've kind of made it more like stop based, where you're more art directing the fuel instead of actually giving it like a fuel, and having the temperature burn the fuel and add combustion. Or yeah, where that's more like art director friendly. We're like at big studios like at Weta, you know, they still calculate fuel, and they like a lot of those questions can still be asked in interviews for that type of stuff, because you know, like if you're doing like a gasoline can exploding, like that's gonna look a lot different, you know. And dialing it in with the artistic skills, it's fine, but like a lot of those people are very technical and like somewhat scientific, so if you can kind of relate to, you know, like what they know, it kind of helps. So the idea today was to I basically just had a set of fluids here, which is just our temperature source, and another set that is our fuel source. So the idea was the temperature rises and then it ignites the fuel. And this one was kind of just made from scratch. So this is like just a 2D example. So we have our temperature, which is white, and our fuel that's blue. And when the temperature and the fuel meet, it creates a burn field, which is purple or pink. And then wherever the burn gets created, then there's basically a density, or what some places call it, soot. So, you know, you can kind of see some of the soot being created and some of the burn happening, kind of creating this basically just kind of the mess of fluids. And this is just our 2D example that we have. So you can kind of see all the soot being created. So the user controls are basically how much divergence. So if you want this to expand like an explosion, wherever the burn is being created, it will also add divergence in that expansion. Especially like in these areas, we should start seeing some sort of expansion happening soon, hopefully. Maybe I have to dial that value or fix those values a little bit more. Yeah, I'm sure we'll see something now. But you can kind of see the green already, but a lot of that's also the velocity. So there's controls for that, which okay, that was working. Okay. There's also controls for soot amount, so if you don't want any density being created, you know, you could obviously turn that to 0. So the idea is to basically those 3 fuel types for the flamethrower is to possibly create 3 temperature sources, and control the burn rates and how much density and or soot is being created for each one to hopefully kind of add some more realism to each of these like material flames, like I'm gonna call them. There's a little less soot, and then there's also like fuel inefficiency, so how efficient you want the fuel to burn, which some weird stuff going on there. You can kind of see more of the divergence happening now with the fuel efficiency. Turned up pretty high. Yeah, exactly. Yeah, so I think by default I'm not going to advect any of these fuels. I just kind of have it in here. But if I have it pretty low, you can kind of see it's a little more stable. But then, yeah, it's starting to happen again. At least we know it's all kind of working. So, yeah, it's usually the fuel inefficiency, and then there's also the burn rate. So, the burn rate is just going to control how much of that's getting burned immediately. And even if you have the soot set to default, which is 1, it's still gonna create it should create very minimal soot still. It's all weird. It seems like some of the stuff is working from the old Houdini and some of it really isn't at all, which is fun. But I think these rules will help. So I did all of that and currently testing it with like the 3 fuels. So I'm trying to see now if extra temperature gets created. So we could see the soot get created. And that's the divergence. So maybe I should just have the divergence turned off completely for this test. So maybe we do not copy or clamp, and we just update the flame fields. Active. No divergence. Oh, I see. So using the particles as fuel. Actually, I've seen that before where like they'll emit make like little hairs out of the particles. So one end is fuel and I think the other one's like a temperature. So I think this is working. So combine all of them. That's not good. Yeah, the padding seems to... Oh, that's why. Let's turn those on. Okay. Is that why you think they got rid of it completely? Because it's just too hard to art direct that type of stuff by default? I mean, that would make sense why they would simplify it. Cool. So the other thing I want to try, so I give the diesel high burn rate. Make sure there's no divergence. Hey, good morning. Magic's going alright. We're just kind of going a little deep with Microsolvers. Putting like fuel back into sparse pyro, which I originally thought it was going to be a good idea to do it for like the flamethrower stuff, to have like different fuel mixtures, but I think it's turning more into an experiment and less as something that's going to be usable. So you can kind of see the 3 different fuel mixtures now getting advected, and then the idea was to have each one of them burn differently and create and contribute to the fire differently. Yeah, it's blowing out of proportion. I tend to like to overcomplicate things. But I always think, you know, doing more development, you're gonna get a better result in the long run anyways. At least that's how it seems it used to be, but now it's more about how quickly you could do it. So it's actually working, which I'm happy about. But yeah, I don't think it's going to be very usable. Yeah, that'd be dope. Yeah. Oh, something's happening. They actually did a lot, like with How to Train Your Dragon 3. there's like that big waterfall caldera, and they spent like 5 months developing the waterfall for that. Super cool. Like, it's such a cool waterfall. Like, and it was done on like I think 10 computers. Um, but like that was like, I swear, the last movie. That was the first movie I worked on at DreamWorks, and that was the last one they spent that much time on development. Yeah, so I think this is just an experiment that went wrong, but I think we've learned a valuable lesson with it. Plus, like, kind of going through our own microsolvers, and this is like the default gas combustion, and I kind of went inside and rebuilt it all from scratch. Uh, Even though a lot of this isn't even used anymore, so yeah, experiment gone wrong. uh, so I think since this failed, the next approach is going to be reworking the fuel setups then with the flames themselves. So I was reading more online about like how these fuels behave differently, because like since napalm is more viscous, it tends to stick, and it's like more blobby. And then you have gas that's more like phosphorus, where it turns more into a spray and ignites immediately. And then we have diesel that like takes a lot more temperature for it to burn. So yeah, I think we're just going to be experimenting with the emitter for the flip sims, and then use those particles more, which I think that was like that was determining a lot of the look of what we were getting before. So going back and I think dialing that in more will help, because this is kind of like really boring looking, just like some particles shooting out, and then we need to just kind of customize that some more, which I still might have this for now for shooting out, and then just kind of dial it down here, because documentation test cases. Yeah, like SIGGRAPH I guess would be the best. Yeah, I mean, yeah, client is gonna be like, I want Michael Bay explosions. I don't want J.J. Abrams explosions. that tends to be the lingo in the industry. Is just people think stuff like that. One funny thing was like on Abominable, there's like the magic with the creature, and they kept describing the magic like in levels. Like, so they're like, oh well, we want level 3 magic happening on these shots, and then we want level 7 magic or level 10 magic happening on these shots. And then the concept art is very roughly drawn, so you're just in your head, you're just like, what the hell is level 10 magic compared to level 2 or 3 magic? But like, that's like our job as the artist to figure that out, just by looking at the art and being like, okay, yeah, it's about what's believable. But I don't know, reference is always the best key to success, I feel like. So yeah, we'll take a look at this. So, because I think the velocity that I'm spraying here, like this, I think velocity would work a lot better with just the gas emission. So we could just test the gas without doing too much work. So I'm gonna get rid of the red and the blue completely. So it should just be gas. And then hit play. There we go. So let's just frame it and then we can dial it in a little better. Okay. So if that needs to spray more and burn up quicker, I'm gonna turn up the noise. Yeah. And I think the burn rate for the gas or the age variance will add slightly less max. And then for droplets, I think we need to increase so they spray and die quicker. Yeah. And I might just be birthing too many. So I think I'm just gonna turn off the receding. Yeah, so I think maybe the spray. Yeah, I might be calling it again. It's getting a little late for me, but yeah, thank you for hanging out or tuning in. I need to watch your streams. I've been seeing some of your VODs, like some of the games. Yeah, it'd be cool. And you're not alone anymore. Now you're linked up with Twitch and YouTube. So you can see the chats from those streams too. Yeah. Yeah, you dial the resolution back. Okay, so that's dialing it back too much. lower that detection, I think. So okay. So I think that's dialed in, or dialed in enough. So instead of calculating and doing the velocity here, go down here. And then since we have the groups, we could just split it up in the groups. Or actually use a blast node. So that's for gas. So gas. So isolate just the gas. The velocity. And then now we could just test the napalm one. Why? There we go. Okay, so for napalm, I mean, that's going to be sticky, so UV the ground plane. And then I guess I'll add an extra wall. I make it sticky. Actually, before I do anything, keep that in that gas just in case. I don't think the napalm's sticky enough. Then bounce. Okay. You can find reference. Yeah, reference time. That's actually really cool. I love people with the idea of like burning down their own cars. I don't get that. I don't think this is all napalm. Oh. Guy just talking about flamethrowers? Oh, nope, there we go. Okay. So my first thought is I have too much liquid. So I think what I can just do is use a fuse node here, and then snap it divided by 2, and then just apply to the napalm. There we go. Then I guess I'm gonna have the napalm live a lot longer, so maybe like 2 times as long. And I think I got rid of too much. So okay, maybe that will work. Then I just need to plug in, turn all my drag forces on. Cool. So now I should have to be able to combine gas and napalm. Merge. And I don't know why every time I scrub it here, the whole thing tries to simulate, even though I'm not viewing it. So I could try like 50-50. Yeah, I had a feeling this would happen, so I think combining them might be the best approach. Just see what that looks like. Yeah. Which I think maybe the gas needs to die way sooner. I have a feeling the gas is what causes the large spreads, and then the napalm is what causes like these very like thin. Gas, so still too much. Guess what's yeah, maybe I want this type of spread happening inside. So we could do this in a SOP solver and then use age. So can make float age as equals it. And then Yeah. So hopefully it spreads more over age. Actually, I could just do like a pop. Wind. Not ideal. Hmm. Hmm. Okay. Okay, it's kind of working. So over age, it's 10 to spraying. And this is definitely going to change the age here, but that's when we normalize it, and then we do age. Okay, yeah, that's still not quite working. Let's crank it up. Or this maybe the best approach might be to so we can make a temporary velocity and name that splash V. So then we have the original vector stored as that attribute. And then let's make another wrangle. plus equals to our splash velocity. And then with the splash velocity, I guess we still have to do an age mask, but I'll look at the proper numbers. So float age normalized is equal to at age by at life. And then we just multiply that. If we just look at the age here, so yeah, it's very short. So I'm just gonna fit that. From 0 to 0.05, from 0 to 1. Oh, you know, it'd probably help if I was actually looking at it in the sim. Okay. So what that looks like without killing. Yeah, this is interesting why this is not. I mean, it looks kind of cool with the sheeting down here, but that's not anything close to the reference. Like, I guess there's some stuff like that happening at the initial. Oh, wait. What am I doing? I can just add that here. So I'm gonna say fit age here, and the age life I'm setting here. And then the age life that's being created here. I mean, I don't get why I can't just crank that number up. Yeah. I guess the other way I could do this is making this less fluid anyways by lessening the density of the water. And then I could leave the initial velocity still at like a spraying. And then you go back here. And I'll back in the spray. What else is happening here? It seems like we just lost all that detail. But oh my god, okay, sorry. Getting a little too late over here. Alright. Because I had it commented out. So yeah. There we go. So we are getting some more of that, I guess, initial spray. And then that natural spread. And I'm gonna make the spray a little bit more aggressive and then really kind of kill it off faster. Yeah. Like 1.5. There we go. Okay. So we'll call that one done. So if we combine them, we have the napalm, which is more stringy and sticky. It would be nicer to keep it stringier. Do I have the preset for that? No. Actually, my insops. Fill gaps. So we could try filling in the gaps I should keep it stringier longer. And even try turning on the reseating. Here we go. Kind of dial this out of here too. Back, pin this window, and then hit P. So max points 10, gap size 0 2 0 2 3, and the radius 6 6. Okay. So should have a little bit more. Yeah. And then the red particles, I'm gonna add a way more drag. So it fit our edge mask. From 0.5 to 0.8. One. Just crank up that air resistance. Like 3. So now the red particles that we're seeing here should have more air resistance. Probably need to actually invert that mask. There we go. And that's killing it off very fast, so go back to 1. Maybe we'll adjust the mask to 0.7, 5 to 9. And we'll dial that back down to like 4 or 5. Actually, so I'm gonna copy this one for, I think that will work a lot better for the gas. So I'll just kill this wind. So combine them now. We have our spray, and then we have the thinner liquid continuing, which that one hits the wall and sticks. And then I think for our last one, I'm just going to copy the napalm, but we're just going to have it live way longer and be a little less viscous. Which, oh, that's the other thing I need to add to the napalm fluid. That's the gas, so napalm, you can really crank up the receding and then add viscosity. And then probably a viscosity of 100. Which it's a little too much, so 10. Try it. Yeah, it's feeling a little goopy. And then I think it might be too sticky, so okay. Well, I think I'm gonna call that here for tonight, or for morning for you, you guys. I could pick this back up. We will finish the viscous fluids and dialing those back in instead of all the other microsolver stuff I was messing with earlier. Yeah, we're getting some fluid sticking, so we'll just have to mess with that and crank up the receding and all that type of stuff. So yeah, that's gonna be it for tonight. Thank you again for those of you watching. I'll see you later. Have a good night.